strategies of development. So let's talk about how to install Synthea. So if you go to the Synthea website, it's a wonderful utility developed, I think, originally at MITRE. Now there's a Synthetic Health, which manages it, but it's a synthetic patient generation utility. Realistic health data, no cost, no restrictions. You go to GitHub and you will find the web page. And this talk is going to present a lot of slides and a lot of web pages and terminal screens that might be difficult to read. What I would suggest is don't worry about it too much. The slides will be available where you can go get that URL or that one bit of that one command, but we want to do the high level overview. So we have the Synthetic Health and the Synthea page, and on that website in the wiki, you'll find a developer setup script, and it's got prerequisites of how to install, how to download the application, how to build it for the first time, and then how to run it. So you get the source code, you have to compile it, then you run it. It does require something called Gradle, which is a Java framework, not JavaScript. It's in Java. So you'll need to install Gradle to begin with. Having that in place, you download the application and get it running in your terminal. And the first time that you run it, it's going to kick out a bunch of errors and warnings and so forth. But what you're looking for when installing it is this executable bar down at the bottom. If you haven't gotten it executing, then you're not, you need to do the installation a little bit more. Eventually, you'll get the build successful message when the Synthea utility has been compiled. Afterwards, you do that, and for the first time, if you can see up here at the top, you run Gradle run, and when you run it for the first time, it's going to load up all these submodules that it has about their clinical workflow and different conditions and all the things that it knows about. You'll see the executing again, and what you're looking for is for it to generate a message here, and you'll see that it says population 1 and seed 159. We just generated a single patient, and so that first one, and it's giving some parameters of our population of 1, minimum age, maximum age, and so forth. And so our patient here that we just ran was Dooley Soon, and we just created a virtual patient. And we're going to take that basic little process and we're going to really expand on it and grow it out into a whole virtual population and cohort. So we're going to talk about the Synthea module builder next. The module builder is a graphical user interface that Synthetic Health has built. And if you go into the wiki, there's a link for the module builder. And it will it opens up into this big canvasy application, and there's going to be this modal dialog with all these different modules that you can select through. So at the beginning of COVID-19, we were going through and scrambling, saying, well, do any of these relate? Are any of them respiratory in nature? And we were like, well, COPD, that kind of fits. That's a little bit in the ballpark. And so let's open up the COPD module. And we open it up, and it turns out that for the past few years, people have been modeling a COPD workflow with Synthea, and we have some sort of data model here. And I want to walk you through some of this. So if you know what Markov chains and Markov generators and state machines are, this is kind of what's happening in the background. Someone from Synthetic Health or MITRE might correct me on that, but the general flow is we're going to have these nodes that the data flows through, and it has a initial, like a begin point and a stop point, and we add the nodes in with all this kind of if-else logic, and some of these nodes will have logic about how to add a SNOMED or LOINC code, and we'll be adding an encounter or condition or so forth to the pipeline. So as we do this, I want to step back and look at the builder as a utility. And we have some controls over on the left-hand side I want to draw your attention to. The first page has some module remarks and some descriptive text notes that you should be aware of when using it. But we go down to the next button, and the next button down, we have a JSON representation of the workflow. So it's all coded up as a structured data element. And we go through, we also have a state list, which allows us some graphical user interface to control the different nodes. We have an attributes list, warnings, and related modules. So in larger workflows, you can bring in submodules. But what we want to do is we want to go back to that JSON representation. So we have the visual display of the pipeline, the data pipeline, in this case COPD, and we have our JSON config file here, and you can copy and paste that config file, which is really important. So you can copy it and then go to your favorite editor like Visual Studio Code or Atom or whatever, Notepad, and you can take, you can get that data out and be working on the raw JSON in the editor of your choice. And conversely, there's a paste JSON option where after you've edited it in your program or your Notepad, whatever, you can go in here and you can paste that data back in. And so we have like the import, input export functionality, which lets us add this as part of our data pipelining to other projects. So back to our COPD pipeline. Okay, so pandemic outbreak. About 3 or 4 months ago, national emergency was declared, and people started scrambling about COVID-19. At the time, like many things do, you know, we were in a chat session, and you can go and read the post later, but there was a pandemic hackathon stream where I posted something saying, hey, you know, there's no COVID-19 module in Synthea. Are there alternatives? Are people working on it? And Jason Wolonsky chimed in and said, oh, you know, we've got a little thing going. So, so that's kind of how that started. And GitHub issue 679 was logged and created for creating a COVID-19 module. So there'd been a couple of different posts, and I kind of chimed in. Like my background, I've worked at hospitals and ERs and ICUs and ORs, and I was just like, hey, look, here's a basic workflow for pre-hospitalization and the hospitalization workflow. And like a lot of collaborations do, sometimes it just requires a couple different parties to toss some things out. And Jason was kind enough to take some of that preliminary workflow and code it up into a file. And we should have these SNOMED codes and these LOINC codes. And when developing a new module for COVID, like this process should be part of the process is to do research before you do the module, to do codings and to look up the LOINC and SNOMED codes. And so you have to kind of do this prep work before building the module. But let's take a look at the first release. This is our first release. This was version 1 of it. And there were about, I don't know, 15, 16, 17 different nodes in the pipeline. Roughly speaking, we modeled it at the time of wait until outbreak, wait until exposure, encounter for test, cough, take temperature, fever, shortness, suspected COVID-19, end exposure, wait for admission, and pneumonia. So at the time, we had a real rudimentary idea of what was going on, but we had a little bit enough from COPD to say, well, we can ballpark this. In hindsight, we really we made an assumption that all these conditions would happen during the test, and we now know that that's probably not correct. But science, we revise things as we move forward. So, so with that initial data pipeline, even though it was in hindsight not 100% correct, we had enough to move forward. And let's talk about generating test data. So when you're back in your terminal using Synthea, you're going to be looking for, when you first run it, you want to go into this source main resources file, and you're looking for this Synthea.properties file, which will, when you open it up, it has a lot of parameters for, like, do you want to export into DSTU2 or STU3, and do you want a CCDA document? Do you want to include smokers? Do you want dead people? Do you want, and it has all these parameters for how Synthea should run in general. So you need to configure your configuration properties file before making the big runs. Once they're done, you can go in and look at the modules that we have. And there's going to be a COVID-19 file that you're looking for. You take that file, and if you open it up and you can inspect it, this should be the same thing that we were editing in the module builder, but now we've taken it out of the module builder and we're running it in the terminal because we're going to be generating a lot of patients. So we do that, and here's the magic command that kind of kicks everything off. We run Synthea, and then this -s, we give it a seed. And if you've not worked with simulation utilities, this is the idea is that you want to be able to run one of these. You want to be able to replicate the synthetic data. You don't want it to be completely random. You want to be able to actually repeat the randomness, and the seed value is what allows that. Then after the seed, you have the COVID-19 file, and you can, Synthea has a little bit of ability to pull in like multiple modules at the same time, so you can kind of search and replace that. But we tell it, look in the resources directory and find the file that has COVID-19 in the name. -P1000 means we want to generate 1,000 patients. So give me 1,000 COVID-19 patients with the seed of 1, 2, 3, 4, 5. And then lastly, we want to specify Illinois and the city of Chicago. And so we're going to have 1,000 COVID-19 patients in the city of Chicago. You run a command like that, and it starts doing its thing. It's going to load in submodules. It's going to kind of get everything up and running and working. And we see our cohort, our population summary here. And this time we have 1,000 patients in the population. And then it starts generating patients. And we get a bunch of them. and more, and more. And this is going to just kind of generate for, I don't know, 10 minutes, as long as you put, or like if you put 10,000 patients, it'd probably run for half an hour kind of thing. One of the things to keep in mind or keep an eye on are these deceased patients. When you run Synthea and tell it, give me 1,000 patients, it's going to generate 1,000 living patients. And according to your pipeline, there might be people who die, and it will include those, but not in the 1,000 patient count. So that was an interesting lesson learned. And eventually you'll run it through and it'll give you this build successful, and you will have a directory with 1,000 virtual patients. And each one of these patients is going to have a name. They're going to have an ID, and this is, we're going to get back to this ID. But I humorously, when generating this data, I tend to think of it in a sim city or a sim hospital kind of way. And we've basically generated our population of sims and little virtual people that will populate our synthetic virtual hospital. And yeah, that's kind of what we've done at this point. So with our population of individuals, we need to upload it to a server. We, in this tutorial, are going to be using the FHIR server. Excellent, excellent product. And there is a free version which you can go and download and install. You can, the instructions are on the site, but suffice it to say that you're going to run it back in the terminal, and it's going to be a different terminal from the tag uploader and Synthea. So you're kind of like a third terminal at this point. You run FHIR CLI, run server. R4, this is like which version of FHIR. So we specified in Synthea that we want version 4. We're going to do the same here. And it'll give some status as it outputs. In particular, you're looking for this base R4 path name at the end. But when you have that running, the server's ready to receive data. And now we can use the tag uploader utility. This is provided by Smart on FHIR, and lovely little utility. It's very simple. We're going to we're going to use node. We're going to run the index file. The output of Synthea becomes the input of the tag loader. So even though the directory name is Synthea output, that's going to be our input directory for the tag uploader. We give it a tag, in this case, DevDays 2020 COVID-19 Synthea. And then the export is going to be the server where the uploader uploads all the data to. And it's going to have another process loading kind of thing. And this too can take half an hour depending on how fast the server is. And it loads, and it loads, and eventually it will be successful. And here we can see 1,079 resources uploaded. So it just uploaded the living and the dead patients, the entire cohort, but there should be 1,000 living COVID-19 patients in the server now. At this point, we can use Postman, which is another lovely utility, and we can query our local host, the local FHIR server, on base R4/patient, and get a giant bundle of 1,085 patients. We had 6 patients left over from a previous run, but we have the 1,079 that we just uploaded. So we uploaded our patients, and you can grab one of those IDs, stick it at the end of the patient URL, and spot check a single patient. And if you open up this patient, it's got encounters and conditions and procedures that we auto-generated from our pipeline. So at this point, we go back into the collaborative nature of building this with open source tools and so forth. And we're back to the Zulip channel, and there was another conversation where I was like, hey, cool, I got it working on my local server. And is this available to, is there a public server that we can upload this to? At which point the kind James Agnew stepped in and said, yeah, sure, I got some servers that you can upload this to. So we run the utility again, but now we're doing it to the public servers rather than localhost. And we run that again and report back, and we're like, hey, now we're checking the public servers, and yeah, this is working. Like we can query all these different endpoints, and we are receiving the Synthea data that we generated. So this is all working and success, like moving forward. More conversation, and then we use Postman, we spot check the public server, and at this point, we've generated synthetic data, we've uploaded it into our Happy server, and we verified it with Postman. So we're doing great. We're ready to actually build utilities and applications with this COVID-19 data. And to do that, let's talk about the second release. So once we started developing utilities, we realized that our initial version of Synthea wasn't 100%. We were constantly still, reports and articles coming in, grabbing them, looking at, trying to code them up. What's a SNOMED? What's the LOINC on this? And exchanging data, research, medications, looking up ARC's norm codes, and risk factors. And so we're putting this all together, editing that config file, and now our pipeline is much bigger. It's more robust. There's a good 50 plus items in it at this point. At this point, it's starting to get interesting, and we can start seeing almost a structural backbone of different workflow phases that we're recording and elucidating. And you count those up, and there's 8 of them of note, and we can describe them as symptoms, like when COVID-19 starts expressing itself, the testing phase, self-isolation, we have when severe symptoms set in. We identify this first responder phase, and then the actual inpatient when they get admitted, and then into recovery, and then finally we have a little bit of algorithm cleanup. So, so that first phase for symptoms, we track things like cough and temperature and fever and shortness of breath, and we add a node for each one of those that will write the SNOMED or LOINC in. Likewise, the testing phase, we made a presumption that there would be a negative pressure room, which I think in future versions will make a question about whether it should be in that phase or a later phase. But you get the administering the test, you end the encounter, and then you have the self-isolation at home. And this gets kind of a different, this isn't quite so much a pipeline at this point. We have a decision-making node, and this isn't technically a Markov generator, but it's a logic tree. It's a branching node where we give it statistical probabilities of which path we're going to go down, whether they get admitted or whether they die or whether they're fine. Afterwards, this would be the severe testing phase where dehydration, gastrointestinal issues, vomiting, and pneumonia set in. After that, our first responder is when we start providing oxygen therapy. We have respiratory distress, but we're also giving metered dose inhalers and our first application of oxygen, which is a real life-saving activity in COVID-19. Then we do the inpatient, where people are starting to be treated by the antivirals, the hydroxychloroquine, acetaminophen, and the treatment in the inpatient. Which leads us to our, does the cytokine suppression work, and are we going to get into recovery? And we have another one of these kind of statistical probability nodes where we model out, is it successful or not? And then lastly, we have a cleanup phase that just kind of ends everything. A lot of these, the FHIR specification requires like periods for the beginning and end of conditions. And this is some wrap up that closes out those date objects in the data. So with all that, we actually have a third version of the COVID-19 module, which was used for the SANER Connectathon 24, where we went and this is a much shorter module because it's using submodules. And if you load the most recent version of Synthea, you'll actually get a whole stack of pipelines that include things, modules for supplies, for stroke, for bacterial infection, for medications. And these were put in place to help create synthetic data for the bed count and ventilator count reporting project that SANER is part of. So that's a little bit of the third version. So with all that in place, we have, let's actually kind of look at building an application. The Node on FHIR is a selection of open source JavaScript utilities that are all FHIRized or use FHIR in some capacity, and kind of builds them together in a stack. And it kind of creates a WordPress style architecture, and you can create plugins. So we grabbed a Node on FHIR and we created a new plugin, and that plugin can be found on the COVID-19 on FHIR repository. And we added that plugin in. And so here's an example of a web application that is coded up to query that happy server for COVID-19 data. And so with the Loink and SNOMED codes, we can write the URLs. We have the FHIR server here, we have a date range, and then these buttons here behind the scenes, they trigger an HTTP call and say, hey, can I fetch some data? Can I fetch a patient list of patients? Can I fetch a list of conditions? And you run that, and we're starting to pull the encounters from the happy server. And so this is the same thing that's happening as Postman, but it's within a nice user interface. And we can also cross-reference and fetch the patients, and we can query the observations and procedures and encounters. And now all of a sudden, we have a whole application. We're pulling COVID-19 data, and we're able to step forward with application development without necessarily being constrained with that question of how do I get any data? And it's a beautiful thing. And so we have, so in this talk today, we presented Synthea and how we generate virtual patients and their records, how to use a tag uploader utility to put it into a happy server. And we also used Postman and an open source JavaScript web application framework to fetch that data and do a proof of concept prototype that has that data. Thank you. And I'd be happy to take Q&A now.
So Rick Geimer is our moderator, and you're on, Rick?
Yep. Can you hear me?
Yep.
All right, great. So we've got a few questions posted. So Abigail, the first one is, what's the vetting process for adding a module into Synthea?
Well, so what I would describe it as is if you can prove, like think of it as scientific process. You need to be able to back it up with research. Like if you can just do some research and like, yeah, have peer review. You know, don't do it by yourself, is have a conversation with somebody and do it with collaborative iteration, and that will be the far better path to success in getting it approved. Healthcare isn't a solo endeavor, it's a team sport. So get collaboration, get peer review, and the vetting will probably take care of itself.
Okay, so don't just come with an idea, come with data. All right, next question is, what's the largest data set you've generated using Synthea? And one of the viewers mentioned SynMass, which is over 200K, I believe. Is that the largest that you're aware of, or have you heard of others?
No, I think Microsoft has done internally some larger ones. Synthetic mass was certainly a good beefy sized one. I feel like Microsoft has done bigger, but like I find that 1,000 to 5,000 patients is what's useful for development, but you could certainly do larger. We've certainly seen ones where people were like, let's do 1 million patients. But yeah.
Okay. Next, there's one housekeeping one about where to download the presentation. I think that's probably in your email. Is there a next one is there a way to get realistic names without numeric suffixes? And one of the attendees said they believe that's a configuration
right.
issue.
I think that's in that Synthea properties file, and you can adjust that. And if not, I imagine that would be an issue that if you requested a feature change, that people would be like, oh yeah, let's add that in. I'm pretty sure it's in the properties file.
Okay, great. Next one, does the module cover complications that could arise with COVID and treatments for those complications, or just the flow of the patient through the hospital?
Yeah. So I had some options of which pipeline to use, and I actually we're on like version 3 or 4 at this point, but I actually wanted to present on version 2 because of exactly that problem. Is it's now getting robust enough that people are making different pipelines for different purposes. And so to the question, yes, you can absolutely add conditional like effects. What happens is you add some of those in, and the more you make it to simulate this one thing, it can make it less applicable to another. So there's a little bit of you know, Wild West, people sorting it out right now, but yes, you can add that in. And what I would say is do it locally first, submit it as a pull request, and then people will go back and forth and say, well, should this be pulled into the main branch or not? But yeah, absolutely doable, and that's kind of what we're actively doing now.
All right, great, thanks. Another one here is what tool did you use, or how in an automated fashion did you test the output data? Paraphrased it a bit.
Ooh, tough question. Yeah, so we have a whole population health dashboard, which I didn't show in this talk, and that took a considerable amount of effort. It's a non-trivial question, and you have to build out a utility to do that. And we use statistical analysis. We use plot graphs. We use swarm graphs. We use you just kind of have to do this population analysis on it, and it's fuzzy and requires some statistical thinking.
Okay, thank you. And last one is, does the latest version of Synthea have COVID-19 v3 submodules?
Yeah, so those would be the SANER modules. Roughly speaking, those are the V3 modules. And
okay.
Yes, it does. And in fact, I will try to post the commit for the V2 because V2 might actually be a little difficult to find. It's now historical, and you get V3 by default, which will include the SANER modules.
Okay. And one just popped up. Is release 2 available at GitHub or elsewhere?
Yeah, it's in there. It's in the main Synthea module, but you might want to go to the easiest way to get to it would be to go into the issue 679, where we were having the big long discussion, and you can find links to it there. It's probably in a pull request, but it's in there, yes.
All right, very good. Well, I think that was it for the questions that I see. So Dave, back to you, or Abigail, if you have any wrap-up comments.
Thank you so much.
Thank you, Rick. And Abigail, I'm not sure if you have any more to add to your presentation. I would go ahead.
It was great. Thank you for having me and allowing me to present.
Okay, and I want to remind everybody that the recording will be placed in Whova on this agenda item by tomorrow. And I know there was a question, how do we get the slide decks? As staff, we are collecting the slides. I need to find out where ultimately those will be available to the registrants, but it will be communicated where you can find the slides, so they will be available. So thank you, everyone. Enjoy the rest of your day. Goodbye.